Hi there, welcome to Ethio-Hahu tutorial. Today we are going to see about motion in two dimensions. Consider a particle moving along a curved path in xy plane. This is the path that a particle follows. R1 is the initial position of the particle and R2 is the final position of the particle. Therefore, the particle is initially at this point and finally the particle reaches this point, and this is the trajectory of the particle. As the particle moves from point P to point Q, point P is this one and point Q is this one. As the particle moves from point P to point Q, what is the displacement made by the particle? As I have said, this is the origin. The initial position of the particle at point P is R1 and the final position of the particle at point Q is R2. The displacement made by the particle is delta R. This is delta R. But R1 can be resolved into two components. It has X component, X1, and Y component, Y1. R2 is also resolved into two components, X2 and Y2. Therefore, this displacement delta R has two components. One is X component, this one, delta X. This delta X is from this point to this point, x2 minus x1. Delta X is equal to x2 minus x1. And delta Y is this one, from this point to this point. This is delta Y. Delta Y is from this point to this point is y2. And from this point to this point is y1, this one. Delta Y is equal to y2 minus y1. Therefore, delta R is written in terms of delta X in the I direction plus delta Y in the J direction. And this is the displacement made by the particle. The displacement of the particle is given by this delta R is equal to R2 minus R1, where R2 is X2 in the I plus Y2 in the J, and R1 is X1 in the I plus Y1 in the J. R1 is equal to X1 I plus Y1 J. R2 is X2 I plus Y2 J. If we substitute for R2, X2 I plus Y2 J is equal to X2 I plus Y2 J minus R1 is X1 I plus Y1 J. Let's collect X components together. X2 minus X1. X2 minus X1 I plus Y2 minus Y1 J. But X2 minus X1 is delta X. X2 is from this point to this point and X1 is from this point to this point. This is delta X. Delta X I plus Y2 minus Y1 is delta Y J. Therefore, the displacement made by the particle delta R is equal to R2 minus R1, and this is equal to delta Xi plus delta Yj. This is our first equation. Next, average velocity of the particle is defined as V average is equal to the time rate of change of displacement delta R by delta T. The displacement made by the particle is delta R. This displacement is made in a time interval delta T. Therefore, average velocity is equal to delta R divided by delta T, where delta R is delta Xi plus delta Yj, dividing it by delta T, delta Xi divided by delta T plus delta Yj divided by delta T. But delta X by delta T is average velocity along the x-axis, and delta Y by delta T is average velocity along the y-axis. Therefore, this implies V average is equal to V average along the x-axis I plus V average along the y-axis J, where V average along the x-axis is equal to delta X by delta T, and V average along the y-axis is equal to delta Y by delta T. Instantaneous velocity is the limit of the average velocity as delta T approaches to 0. That is, instantaneous velocity is limit as delta T approaches 0 of the time rate of change of displacement. And this is equal to limit as delta T approaches 0 of delta R by delta T is delta Xi by delta t plus delta y j divided by delta t. And this is equal to instantaneous velocity into dimensions, having x component and y component. This means that Vx is equal to limit as delta t approach 0 of delta x by delta t. This is average velocity, but the limit as delta t approach 0 of average velocity along the x-axis is instantaneous velocity along the x-axis, and Vy is equal to limit as delta t approach 0 of delta y by delta t, because this limit is used for delta x by delta t and delta y by delta t. The instantaneous speed of the particle is simply the magnitude of this velocity. The magnitude of this velocity is simply obtained using Pythagoras theorem. That is the square root of Vx square plus Vy square, because V square is equal to V dot V, and this is equal to Vxi plus Vyj dot V is also Vxi plus Vyj. Vx times Vx square, I dot I is 1 plus Vx times Vy, I dot j. Since I and j are orthogonal to each other, I dot j is 0. J dot I is also 0. Vy times Vy square, j dot j 1. Therefore, V square is equal to Vx square plus Vy square, and the magnitude of velocity is equal to simply the square root of Vx square plus Vy square, and this is a magnitude of the velocity or the speed of the particle. Average acceleration of the particle is defined as the time rate of change of velocity. Since V is Vxi plus Vyj, change in V is simply change in Vxi plus Vyj. This is equal to change in Vxi plus change in Vyj. If you substitute for change in V, change in Vxi plus change in Vyj divided by delta t, we have this. Therefore, average acceleration is simply the time rate of change of velocity along the x-axis in the I plus the time rate of change of velocity along the y-axis j. This is equal to average acceleration along the x-axis I plus average acceleration along the y-axis j, where average acceleration along the x-axis is equal to the time rate of change of velocity along the x-axis, and average acceleration along the y-axis is equal to the time rate of change of velocity along the y-axis. Instantaneous acceleration is the limit of average acceleration as delta t approach 0. That is, limit as delta t approach 0 of the time rate of change of velocity along the x-axis I plus the time rate of change of velocity along the y-axis j, and this is equal to limit as delta t approach 0 of change in Vx by change in Ti plus limit as delta t approach 0 of change in Vyj by delta t. And this is instantaneous acceleration along the x-axis I plus this is instantaneous acceleration along the y-axis j. Therefore, total acceleration is equal to xi plus ayj. The magnitude of this acceleration is simply the square root of x square plus ay square. A square is equal to a dot a, and simply this is equal to ax square plus ay square. The magnitude of a is equal to the square root of x square plus ay square. Let's see example. A particle moves along a curved path in the xy plane. Its trajectory is given by the equation r of t is equal to 2 meter per second square t square I plus 5 meter per second t j. A. Calculate the average velocity in the time interval between t is equal to 0 and t is equal to 2 seconds. Solution. A. R of t is 2t square I plus 5t j. But r at t is equal to 0. The initial position at t is equal to 0 at the initial time is 2 times 0 square I plus 5 times 0j. This is equal to 0I plus 0j, or simply 0. The position at t is equal to 2 seconds at the final time. This is equal to 2 into 2 square I plus 5 into 2j. This is equal to 2 square 4 times 2, 8I plus 5 times 2, 10j meter. Therefore, displacement delta R is equal to R at t is equal to 2 seconds minus R at t is equal to 0. This implies R at t is equal to 2 seconds is 8I plus 10j meter minus R at t is equal to 0 is 0. This is equal to simply 8I plus 10j. This is the displacement made by the particle. But average velocity, V average, is defined by delta R by delta t, the time rate of change of displacement. Delta R is 8I plus 10j meter divided by delta t, the time interval between 0 and 2 seconds is 2 seconds. This is equal to 8 by 2, 4I plus 10 by 2, 5j meter per second. This is the average velocity between t is equal to 0 and t is equal to 2 seconds. B. Calculate the velocity of the particle at any time t. R of t is equal to 2t square I plus 5tj. To find the velocity at any time t, let's take the first derivative of this. V at any time t is equal to first derivative of R of t. That is, the derivative of this is 4ti plus 5j. Therefore, velocity at any time t is equal to 4ti plus 5j. This is the velocity of the particle at any instant of time. Calculate the speed of the particle at t is equal to 1 second. Since v at any time t is equal to 4ti plus 5j, velocity at t is equal to 1 second is 4 times 1 I plus 5j. This is equal to 4 times 1 is 4 I plus 5j meter per second. But we want to find the speed. To find the speed, the magnitude of velocity is equal to speed is equal to the square root of vx square plus vy square. This implies the square root of 4 square plus 5 square. This is equal to the square root of 16 plus 25. This is equal to the square root of 41 meter per second. This is the magnitude of the velocity or the speed at t is equal to 1 second. D. Calculate average acceleration in the time interval between t is equal to 0 and t is equal to 2 seconds. Since v at any time t is 4ti plus 5j, we want to find average acceleration between t is equal to 0 and t is equal to 2 seconds. To find average acceleration between 0 and 2 seconds, v at the initial time t is equal to 0. That is 4 times 0 I plus 5j. This is equal to 5j meter per second because 4 times 0 is 0. Velocity at t is equal to 2 seconds. This is equal to 4 times 2 I plus 5j. This is equal to 4 times 2, 8I plus 5j. Therefore, average acceleration is equal to simply the time rate of change of velocity. This is equal to velocity at t is equal to 2 seconds minus velocity at t is equal to 0 divided by delta t, 2 seconds. Velocity at t is equal to 2 seconds is 8I plus 5j, 8I plus 5j meter per second, minus velocity at t is equal to 0 is simply 5j meter per second, divided by delta t is 2 seconds minus 0, 2 seconds. 5j minus 5j goes, we are left with 8I meter per second divided by 2 seconds. 8 by 2, 4 meter per second is meter per second square. This is equal to 4 meter per second square. Therefore, average acceleration is 4 meter per second square. Calculate the acceleration at t is equal to 0, at t is equal to 1, and at t is equal to 2 seconds. Solution. Since again, v of t is equal to 4ti plus 5j is found in b. Instantaneous acceleration. Acceleration at any instant of time is again first derivative of v of t. This is equal to the derivative of this. The derivative of a constant is 0. This is 0. The derivative of 4t is simply 4i meter per second square. Therefore, acceleration at t is equal to 0 is equal to acceleration at t is equal to 1 is equal to acceleration at t is equal to 2 seconds is equal to 4i meter per second square. In general, from this equation has x component, the other one is y component. The x component of the position is second degree polynomial, and the y component of the position is first degree polynomial. If the position of a particle is second degree polynomial, it has a constant acceleration. If the position of a particle is first degree polynomial, it has no acceleration because it moves with constant velocity. Therefore, this part is accelerated part, but the type of acceleration is constant in this case because of this degree. The degree of this component is 2. Due to this, the acceleration of the system is constant along the x-axis. The leading degree of this component is 1. Due to this, this is uniform motion. This one is uniform motion. This one is unaccelerated motion. That's why average acceleration and instantaneous acceleration are the same in A, but the y component of the velocity remains constant because this position is first degree polynomial. And this is all about today. Next time, we are going to see about projectile motion, and have a nice time.